Hi, students and friends. Welcome to the channel Learn and Teach by Ayaz. In this video lesson, I'm going to talk about the topic, the particle model of matter. The level is grade 7, and the book I'm following is International Lower Secondary Science, book 2 by Marshall Cavendish Education. So let's start the video lesson. I have randomly selected the learning outcomes from this topic to recognize that matter can exist in three physical states, to use the particle model of matter to explain and differentiate the three states of matter, to explain the changes in state using the particle model of matter. What is matter? Matter is anything that occupies space and has mass. You see, you have different things around us. These all are counted as matter because these things occupy some space and definitely has some mass. So here are some examples of matter in our daily life: water, salt, oxygen gas, etc. There are many other examples. Name the three physical states of matter: solid, liquid, and gas. In the above example, salt is a solid state of matter, water is the liquid state of matter, and oxygen gas is the gas. Matter is made up of tiny particles. Particle model helps in explaining the three states of matter well. We can explain the arrangement and motion or movement of particles in all the states of matter. The model also helps in explaining other physical characteristics or properties of the three states of matter. You can also predict or suggest the distance and forces between the particles in the three states of matter. So matter is made up of particles, and these particles are always in motion. So if you want to draw the particle model of the three states of matter, it would be like this. For solid, the particles will be very close to each other like this. In case of liquid, the particles are loosely packed. They are not as tightly packed, tightly and closely packed like in solids. Now, in case of gas, the particles are very far away from each other. They have a random arrangement. So if you'll talk about the arrangement of particles, as you have seen in the above diagram, in solid state, they are tightly packed together. You can even write closely packed together. In case of liquid, the particles are loosely packed or further apart. For gases, the particles are far away from each other. You can also write random arrangement. Motion or movement of particles. In solids, the particles do move, but they are just vibrating about their fixed position, which means the solid will not move or leave its original place. In case of the liquid, they are changing places, or you can even write sliding over one another. This is a reason why liquid flow. Now gases, they are moving in all direction, they are everywhere, so they can easily flow just like liquids. The distance between the particles. In solid, the distance is very less, which means they are very tightly and closely packed. But in liquid, they are further apart, and in the gas, they are very far away from each other. Now I'm drawing the particle model again for your convenience. I will just draw the small part of this. For liquids, we have particle sliding. Gases, the particles are very far away from each other. Now let's talk about the forces between the particles. In solid, the particles are very close to each other, so they are joined together through very strong forces. Very strong forces between the particles. In liquids, the force is there, but it's not as strong as in solid. Less strong as compared to solid. But in gases, the forces are non-existent. The reason is that the particles are very far away from each other. If the force is there, then the particles must be close to each other in some way. What about the energy of the particles? So in the gases, the particles are always in motion. They have very high energy. In case of liquids, they have high energy than solid, but lower than gas. High energy than solids. And very low energy because the particles are just vibrating about their fixed position. Here's a diagram. See what will happen when you heat the liquid. You see the particles, they start moving vigorously because they are gaining kinetic energy. The motion and the speed will continue increasing as the heating continues. Now, if we talk about the shape of the solid, they have exact or definite shape. Liquids and gases, they don't have any fixed or definite shape. It takes the shape of the container. Gas also takes the shape of the container. Volume. Solid and liquid both have definite or fixed volume. The perfect example for liquid having fixed volume is that when you drink 1 liter of water, if you transfer that 1 liter of water in measuring cylinder, you will find out that the volume does not change. But in case of gas, it is indefinite. It means the volume of the gas will vary. Due to this reason, gases are compressible. Both solid and liquid can't be compressed. If we talk about the density, solids have higher density, while gases are lighter or having low density. In case of liquids, they have medium density, which means their density will be higher than gas but lower than solid. Now, ease of flow, gases have very high ease of flow, and liquids have medium ease of flow, but solid do not flow at all. Now, let's talk about the changes in state using the particle model of matter. Now, when you heat the solid, it will change to the liquid state. The process is known as melting, and this will take place at a fixed temperature, and we call it melting point. When you heat the liquid, it will change to gas state. We call it boiling, and the temperature at which this process takes place is known as boiling point. Sometimes we also use evaporation or vaporization for the change of liquid into gas state. Now let's talk about the reversal of this process. When gas is cooled to liquid, we call it condensation. In the same way, when liquids are cooled further, they will change into a solid state, and the process is known as freezing. The fixed temperature at which the freezing takes place is known as freezing point. Now, there is a situation when you heat solid, some of the substances like iodine or carbon dioxide and few other substances, they sublime, which means they convert from solid into gas state. So we call this process as sublimation. This is sublimation, which means the solid is converting into the gas state without going through the liquid state. The reverse of this process is known as solidification. Melting, the process in which solid state changes to liquid state. Boiling, the process in which liquid state changes to gas state. Condensation, the process in which gas changes to liquid state. I want you to define freezing by yourself. Sublimation, I've already explained, the process in which solid changes directly into gas state without going through liquid state. Melting point, it is a fixed temperature at which solid changes into liquid state. I hope you people will be able to define both boiling point and freezing point by yourself. Thanks for watching. Press like and comment on my video. For more videos, subscribe to my channel and press the bell icon.